Hi, welcome to Basic Math. Today we're looking at proportions. We're going to be looking specifically at story problems story problems that use proportions and similar figures. So we'll get to the similar figures here in a minute, but let's start talking about these story problems. So nobody likes story problems, at least not much in my experience. Maybe you do, but if you do, you're kind of different. All right. Here's a story problem. Let's read it through and then let's kind of talk about how we're going to go about this. You can see I actually did solve it down at the bottom, but just ignore that for a second. A basketball player makes 70 out of 100 free throws. If they shoot 20 free throws in a game, how many are they expected to make? So this is this is the sort of question that that could actually arise. You have a basketball player who makes a certain percentage of their free throws. How many would you expect them to make in a game? That kind of thing. So here's what we want to do. We are given two ratios in this problem. The first one's really easy to see, 70 out of 100. So you'll notice down here, the very first thing I did was write that 70 out of 100. So then we have a second one that's kind of hiding here. It says, if they shoot 20 free throws in a game, how many are they expected to make? So how many out of 20 is hiding there because it's not worded the way that we would maybe hope to be able to see that ratio really easy. So here's the key to doing story problems with ratios. Make sure your two fractions are lined up. And here's what I mean. 70 out of 100. This ratio is based out of 100 total free throws. Okay, so the 100's on the bottom. That total free throws is on the bottom. Ask yourself, is this 20, is it the total free throws taken in the game, or is it how many they made? You could get an example where it's the other way around, but this one is how many they shot, right? They shoot 20 free throws in a game. That's why I put the 20 on the bottom. I lined it up with the other total that we had, right? 70 out of a total of 100 free throws. Something out of this total of 20 free throws. If you always line them up like that so that the same things are in the same place in the fraction, you're gonna get right answers every single time. You get in trouble if you try and mix them up and then it just doesn't work. So always line them up. And after that, it's just solving the proportion. We cross multiply. 100 times x is 100x. 70 times 20 is 1400. We go ahead and divide both sides by 100, which makes it go away on the left, and leaves us with an answer of 14. And that's it. That's how solving these story problems with proportions works. Line up the things that are the same, then cross multiply and solve it. And it should work every single time. So maybe I'll do one more and then we'll get into the similar figures. Okay, so here is another example of a story problem that we will use proportions for. So remember, what we're looking for to use proportions is we're looking for the presence of ratios. Okay, we need two of them, one where we know the whole ratio and one where something's missing. So here, let's take a look at this one. It says if 10 ounces of a breakfast cereal contains 3 ounces of sugar, how many ounces of cereal would be needed to have 7.5 ounces of sugar? So I've added a decimal into this one. That's going to make things just not much more difficult, but a little bit. All right, so let's take a look. The first bit I see this information about 10 ounces of cereal, right? 10 ounces of cereal, 3 ounces of sugar. So I set up a fraction. I did 10 over 3 because that was the order that they were written in, but they're tied together, so that's why I put them in one fraction. And you can do 10 over 3 or 3 over 10. It's not really going to matter here as long as the second fraction you make then lines up like we talked about in the last example. So I did 10 over 3, and you can see that here. You can see my second fraction too. So let's read the second part now. How many ounces of cereal would be needed to have 7.5 ounces of sugar? This is where we have to be careful. We know that the 3 was ounces of sugar, and it's on the bottom. So this 7.5, which is also ounces of sugar, needs to go on the bottom. And the ounces of cereal that we don't know goes on the top, where the 10 ounces of cereal were before. Again, if you wrote this fraction the other way, if you had 3 over 10, then that would be fine. You would just flip this one over and have 7.5 over n. They just have to line up. Okay, same things, same things. So we cross multiply, 3 times n is 3n, 10 times 7.5 gives us 75. We divide both sides by 3 to get rid of the 3, and that leaves us with the n is 25. Doesn't matter what letter you use, not a bit. I chose n this time, I think I used x on the last one. It really doesn't make any difference. So there you go, that's story problems with proportions. And they can get as weird and messy as you can possibly imagine, but just remember the key. Set up your fractions so that the things that are the same line up, okay, going across the equal sign. All right, let's get to some similar figures. All right, so similar figures. The good news is this is like a story problem where you can see the whole thing, okay, and so that makes it kind of fun. Similar figures are just shapes, okay, that's what we use the word figures for shapes. Shapes where the ratios of the sides are proportional, which means that they're equal. So this should sound familiar. We're going to be setting up proportions, and how do you think we're going to do that? We're going to do it the same way we did with the story problems. We're going to make the same pieces of our shapes now line up. So let's take a look at this example I have over my shoulder, or behind my back, I guess. And we'll see how it works, and really these are pretty straightforward. So let's take a look. Here's my first shape. I have a triangle with two sides that are 3 and 7, and another triangle with sides that are 12 and x. Now, to be similar, they don't have to be the same size, just the ratios of the sides have to be the same. So we have 3 over 7, so we have 3 and 7 for this one. So I set up a ratio, 3 over 7. Now, which side in the big triangle looks like it matches up with the 3 in the small triangle? Well, I hope the answer is 12. That's how I did it for sure. So I put the 12 on top, right? I'm lining up those matching pieces in the triangles. And then the x matches up with the 7. And there we go. I have a 3/7 is equal to 12 over x. That looks like a proportion. So what do? The same thing we've been doing. We cross multiply. 3 times x. 7 times 12 is 84. And then we just divide by 3, which leaves us then with 28. And so that's similar figures. Just remember, match those pieces going across the fractions. Okay, going across that equal sign in the middle. If those match, this is always going to work out for you. So there you go. Good luck.